So what we'll talk about today, the core focus is the installation of our robot crawler, our RC model, which is a printer with a robotic arm on a crawler. We'll talk about the installation preparations. So what do you have to prepare before installing this printer, moving the printer after a print or towards the print site, and then the dry test, which is the test we do without material before we actually start printing to make sure everything is safe. So it's a little bit about preparation and what do you have to do apart from actual printing to make the system work. That's what we'll talk about today. So as you guys know, we like to keep them a little bit interactive, even though this is a pre-recorded one. We do have some live polls as well, which I forgot to tell you about. And I'm curious, what do you think is the most difficult step in the process of getting your machine ready to print? So moving, pre-print preparations, dry testing. Let us know. We're curious to know. A lot of people have different opinions on this. I see a lot of moving the printer, preparing the installation. Yep. Dry testing, correct. Quite simple. Only one person saying that. It's an important step for safety, but it's not complicated. Preparing the installation, moving the printer is still not complicated, but a bit more labor intensive, so to speak. You have to actually do something and not just watch it dry print. So that makes sense. Yep, seems pretty spot on. All right, so we'll head into the first segment of the pre-recorded part, which is about the installation preparation. So enjoy, and if you have any questions during or after, we will be live in the chat to answer those questions. Thank you.
We are now in our production facility, and we are going to show you what you have to prepare and what you have to set up to going to print on site, or for in this case in our facility. Normally you are with 2 or 3 operators, and that's more than enough to get everything prepared in about 30 minutes. The first person is going to drive on the forklift. He is getting everything out of the container or of the truck and is getting everything in place. The second person is getting all the connections ready, so the power supply, electrical connections ready, and doing the final touch. And the third person is working on the robot and doing the dry test and setting up the robot. We are going to show you also later in the webinar how to set up the robot and also how to run a dry test, so you know that everything is prepared and everything is safe to use during the print. I'm going to show you right now all the hardware that is needed for printing, and you have 3 main stations. You have the mixing pump system. On this side you see the mixing pump system, what is providing the material, what is flowing to the robot. We have on the other side we have the robot with the crawler. So this system can be hoisted or lifted with a forklift out of the truck or container and can be lifted on its place and can be driven to the exact location where it needs to print. For the mixing pump system, it has to be driven with a forklift and has to be hoisted with a forklift to get everything in place. So on this side we have the mixing pump system, and what you can see right here are 2 holes for the forklift to get in, so the forklift can hoist or lift everything easily and get everything easily in place. The system has two parts. So you have here, we have the platform with the mixing pump system attached to it, and we have the platform which the operator can standing, so we can get the material in. What you can see right here is the material. We have our own material, as you know, CyBe mortar, and we have, in this case, we have the small bags. You can also have the big bags. In that case, you need a big bag frame, but that's I think something for the next webinar. For the material, it's really important to think about logistics, because you need for big projects you need a lot of material. So if you need a lot of material, you need to think about how to get the material at this direction, and also how to get it in, and also how to get empty pallets out. So that's also a thing to get to think about. In this situation, you can see the mixing pump system on this side, the water and the water connection in the corner, and the control unit. And we have you have to think about the positions where everything is standing. We have now placed the mixing pump system on this side, and we have done that because we want to go to the printing today on that side. And it's always to control the material, the mixing pump system operator needs to know where it's going to print, and also what the quality of the material is. Sometimes you have too much water, sometimes you have to, it's setting too fast, so you have to control the material, you have to control the water and the additive of retarder, so you have the perfect mix. So that's also always a thing to keep in mind, that the mixing pump system operator has a clear view on the robot itself, on the print, and also on the operators, so they can communicate with each other, and they can they can say, okay, you have to raise the water a little bit, or you have to lower the retarder. So on this side you can also see some water connections and power connections. We start with the water. So the mixing pump system needs 3 things, only 4. So the material, water, and retarder. And the water is needs to have a consistent flow. So the material of the water should run through the system with about 200 to 250 liters per hour. But you cannot have any fluctuations. So for that we have used a cubicle. So come with me on this side. We have a cubicle for that. On some places you can also use the direct water tap, because if the water tap gives a consistent flow, the water tap works fine. In this case, just to be sure, we use a cubicle with a water pump, and with the water pump connected with the mixing pump system, the water is always running in a consistent flow, and we don't have to have any concerns of the material of the water is getting a dip or too much with the water. On the mixing pump system itself is also a water pump, and so with a water tap it should work, but just to be sure we like to use a cubicle. On this side you see a green box. That's our cooling unit. For getting the perfect material, you need the water, but it should be on a temperature between 20 and 25 degrees. You can have it a little bit less or a little bit more, but we always recommend have it around 20 to 25 Celsius degrees. In this case we have a cooling unit, because right now the water is quite warm and we have to control it. In some situations, in cold climates or where the water is quite cold, you can use a heating unit. So in that case you connect the water tap or the cubicle with the heating unit, and the heating unit is connected to the mixing pump system. For the electrical system, you need on this side you need two connections. One connection right here, you can walk with me. On this side you have one connection. It is depending on where you live. In the Netherlands we have a 400 volt system, so we have a 30 ampere connection. For the cooling unit you also need 30 amps, but it's depending if you have if you live in a country where you have 200 volts, you have other power requirements. So that's always something where we are discussing with our clients. Where do you live? What kind of electrical system do you have, and what is needed? So this mixed pump system is connected, but also the robot in the back and the control unit. We always advise to don't have to connect them, not everything in the same electrical box. So yeah, keep in mind to when something is going, if too high voltage, the system can collapse, and we don't want to prevent that. So just to be sure, we connect them with several electrical boxes. This can right here is the retarder that we use, and it's pumping always. Also depending on the climate where you live. In hot climates we use less retarder, in warm climates we use a lot. So I think that's about this station. So important material, really important, electrical system, and the water supply, and yeah, this platform, so the mixing platform, is one of the most important things of the whole system. Yeah, so that's platform 1. Now we're going to the control unit. I've got something to tell. If you can zoom in, or I can also take it. So what you see here is our curing gun. It's sprinkling water when we have printed. We have to regulate the water temperature, so we will make the wall a little bit wet to regulate the temperature of the wall itself. So always we use a curing gun. We call it curing gun to sprinkle the walls wet. So that's also a thing. And you see also the yellow part with the blue, and that's the dust extraction. And dust extraction is it prevents that you will inhale a lot of mortar, and it's better for safety. So it's always connected to the system. Now we will go to the control unit, and the control unit is like the heart of the system. Everything what is happening at the robot is happening there, and it's the brain of the robot. So this system will think, and that system will do it. And right now we see also a laptop on it. The laptop, you have like the chisel code. So in a previous webinar, we have explained about how you make a model in Rhino 3D, how you can chisel it, so how you can size the model so the control unit understands what to print. And from that point you have just a folder, and you will upload it on the control unit. I think we have also explained it in our previous webinar, but we will do it also today, and we will show you how you can upload the folder on the control unit, so the control unit knows yeah, how the robot will behave, and what is the printing path. You see a lot of a few connections. So you see these connections, and yeah, there we are.
Great.
You see some connections. Those connections are connected with the robot and with the mixing pump system. So so the robot knows what to do and how to behave, and also the mixing pump system knows when to start. And also, if you need more water or less water, you can regulate it here also on the control unit with the flex pendant, or on the mixing pump itself. This big cable you see here, that's the one that's going underneath the system, and is going through the robot itself. On that side, it's about 8 meters long, so you can drive quite easily some large distances on the construction site. Because yeah, if you have a house, you can place it somewhere. 8 meters is quite a lot. Yeah, so the control unit, and this is the system that is thinking for you, and the robot itself, that's the thing what is doing the actual printing and the movements. And we will show you right in a few minutes how to set up the control unit. So, sorry, the robot. So how to drive with the system, and also how to level the system. Because without leveling, you cannot print always straight lines. So I think that's about it for this part.
All right, welcome back, everybody. Well, for me, not so much for you. You've been here the entire time. Uh, as you can see, during that video, I lost a bit of weight and I put on some glasses. Just kidding. For the people that have been following these webinars, that was, of course, Jesse van Dongen, excuse me, who has been doing these webinars for a long time after me and Quentin took over. So that was him explaining a little bit about the installation. I got a question during this video about the amount of people you need for setup and for printing. In general, we have 2 people at least necessary for printing, one to keep an eye on the robot and the control system, and the other one to keep an eye on the mix and pump system. If the print is more complicated than just a wall or a vase or a simple object, then we like to have another operator with us to take a close look at the object being printed as well as doing some corrections if needed for, let's say, electrical sockets, cutting out some pieces of the print while printing. For the installation of the printer itself, you only need 2 people. That's because you don't have to do a lot of things at the same time. It's not time related during a print, so you can take your time. Usually also doesn't take so long, but we'll talk about the time it takes to move the robot in a little bit. As always, we go to another poll just to see if everyone is still with us, and we're always curious about your answers. So talking about the time you think it would need, how long do you think it will usually take our partners to install their CyBe printer? And then we do not mean between 2 prints. You can also answer that if you want, but we mean from the container after we ship it to them or after they move it from their warehouse to the build site to actually being operational. So taking it off the back of the truck and actually starting a print. How long do you think this will take? We hear a lot of different options. Sometimes people say a couple of minutes. Sometimes people say more than a day. So I'm curious what you guys think. One thing to keep in mind, if you're transporting the printer over long distances, the robot and the crawler will become separated for safety of transport. If it's over a very short distance, you can keep the robot on the crawler when transporting it, depending on the trailer you have. This also, of course, influences the time it takes to set up. I see a lot of 1 hour, 3 hour, 1 day. A couple of people think longer than a day. I will wait for a little bit so everyone gets their answer in. I think that should do it. There we go. We have a tie between 3 hours and 1 day. So the question is, how long do you think it usually takes our partners? And usually it takes our partners around 3 hours. Our personal record in our own facility is 1 hour and 40 minutes. This was not meant as a speed run, but we had a bit of a rush to start printing before the end of the day. So we did it in 1 hour and 40 minutes. But in general, 3 hours is a nice amount of time to assume. So not too long at all. You can take it off the trailer, put everything down, plug it in, put the robot on the crawler, and all of this in 3 hours, and you're ready to start printing, which is quite a lot better than a gantry printer, for example, which takes more than a couple of days to actually set up and calibrate. So a big advantage of a robotic system on a crawler. Another big advantage, of course, due to the tracks, you can move it around on the job site or in your precast facility. We use it for both. And yes, we'll now tell you a little bit about how we do move the printer and what you have to think about while moving your printer.
So in this situation, the crawler is hoisted from the trailer, from the container, to the ground. And from that situation, you can drive it to the exact position where it's have to be printing. You can see it's right now standing on the stamps, and it's always when doing transportation and also doing printing, it's standing on the stamps, and that's to always have a stable and balanced platform. So it's stable because on the tracks itself or the crawler itself, you can it's not balanced enough. So always during transportation and also during printing and standing here on stamps. I'm going to now show you how you can drive with the system and how you can get everything in position. For that we have to go to the other side, to the back of the system, where we can control it. So here we have the electrical cabinet. For driving itself, we always advise to do it with 2 persons because the driving itself it doesn't take long, but it's for safety reasons, because if you are driving on this side with these controls, you cannot clearly see everything. So for driving itself, just ask a colleague to do the driving with you. As you can see right here, we have electrical power connection. Here in the Netherlands we have a 400 volt, so we need a 32 amp, but in some cases you need another power connection. And with this we have, you are ready to drive, so you don't need to always be connected already with the control unit. I'm going to now start the system. It's going to be a little bit noisy because the hydraulic system and the motors are going to turn on. But I can show you, and I can show you how to drive, and also how the stamps are going up. For driving, we are do it in manual, so we have to switch it to hand. The main switch we have to turn it on, and we have to turn the power connection on. Now the power connection is not turning on because on this side you can see the direction of the hydraulic motor. We have to turn it or in 1 or in 2. Go to set it in 2. Then we can turn the system on. And now we have to check the motor right here. Now it's standing on the right side because the direction is now clockwise. But if the motor was turning on the other side, we have to switch this button. But now it's good and it's working. I'm going to start the system, and I'm going to control the system with those jogs. To move the color we use those 2, and for leveling and the stamps we use those 3. And I'm going to show you right now. So first we need to have the stamps up. And do this at the same time. Stamps are up, now we're ready to drive. Driving, you need to have, you can ask your colleague to get the cables and check if everything is free, and you can drive with those. We advise use with 1 hand and 2 hands, but be careful because it's a hand machine. Now we're going to put the stamps up. Now we have to level the system. In leveling, we are going to check the flex pendant, if the system is leveled and if it's good. So check the front, and we check if it's balanced. And we have also our self-leveling system, and with that you can just push the button and the system will level itself. So now we don't have to, if we have it, but we are going to do it manually, and we'll check here if the system is leveled. So I'm checking right now the flex pendant, if the front is good and is balanced, and then we are ready to go. That's perfect. So now we are ready. We're shutting down the system, the hydraulic system.
All right, so that was Jesse moving the printer. As you guys can see, it's not the fastest thing on the earth, but it will have to do. It's better that way for safety reasons as well, of course. You don't want to have a robotic printer racing around the build site. What you could also see is that Jesse did some manual leveling, like he explained. Usually we have an automatic system that does that, so you just press a button and with the gyroscopic sensor, it will level itself using those legs and the automated hydraulics, which saves a lot of time when setting up, because every time you move the printer, you have to re-level it, of course, to make sure that the printer is nice and flat. Other than that, it's putting the stamps up, moving it into the location, and putting them back down. So that takes, as you saw, I believe that video was about 5 minutes, and the actual moving around was about 4 or 3.5 minutes. So depending on the distance, it can be done super fast, especially with the self-leveling. Let's see. This is an interesting one as well, because a lot of people think that the legs are just stabilizing stamps, which is, of course, a big part of what those legs are for, but they do have another functionality. So after properly positioning the printer, what height do you think it can reach using its hydraulic feet? And then we don't mean the legs themselves, but the actual print height. So keep in mind the nozzle or the robotic arm has a reach of around 3.2 meters, not straight up, of course, but that's the reach. And then we have the legs. So there we go. That might have influenced the answers a little bit. So a lot of people still think over 3 meters, which is correct, and over 2 meters is also correct. But the great thing is that over 4 meters is actually the correct answer as well, meaning that if we raise the legs to the absolute top position, we can actually print elements over 4 meters high. And contrary to everyone's belief, we can do this in one go. So from the bottom all the way to the top without stopping. And the reason we can do this is because our material sets so quickly that by the time the weight of the wet material becomes too much to carry, the bottom layers are already cured far enough to carry this weight. This means that we can go for 4 meters in one go, which of course is great for your overall equipment effectiveness, so you don't have to stop in between. What you saw in the video was the hydraulic system, which we call the self-leveling, which has hydraulic legs. We also offer a height control, and in this case it's pretty much the same machine, but the big difference is that the legs, the stabilizing legs or stamps, are actually not powered by a hydraulic cylinder, but by an electrically servo motor controlled linear actuator, which acts as an extended z-axis. So this is a controllable height, which is why we call it height control, and it can actually extend these legs while printing, meaning that you can use this extended z-axis to print higher objects, reaching all the way up to 4.2 meters, which is a nice feature if you want to print higher than the self-leveling, which does about 3.4 meters per standard without moving the legs. So a little bit of information which might be nice to know. Well, as I said in the beginning of the webinar, we also do a dry test before we actually start printing. So after you install your printer, your mix and pump system is ready to go, your robot is ready to go, you've moved the printer to the correct location, you then have a big, fast robotic arm that's going to move at 0.5 meter a second to print something. And what we do to make this safe is we do a dry test at a lower speed from the bottom layer, the middle layer, and the top layer, to check if there's no collisions and if the model has been correctly loaded. I'm kind of spoiling Jesse's part, so let's get right into it. Jesse will tell you something about the dry testing.
So we have set up the mixing pump system, water and power connections, and now the last thing we have to prepare is the robot. For the robot, before we are going to print, we are doing a dry test. And a dry test is running the model and printing without material to check if all the code is good installed and everything is ready to go. For that, we have our chisel in Rhino. So we have our model prepared in Rhino. And if you see right here, you see our model. We already chiseled it. If you are interested about how we did it, we have a webinar about software, and there we explain how to use the software chisel. One thing what is really important to remember is we have our 0.0.0 point on Rhino, and that is also the reference point on the robot. So we have to install the 0.0.0 point on the robot before we can start to print, so the robot knows where to position the object that we are going to print. So we have the chisel code, and what we are going to do on the laptop, we have connected the laptop with the control unit. With our file transfer software, now we use Robot Studio, we will select the folder, the chisel folder, and we'll transfer it to the robot by selecting it and by transferring it like this. Okay. Now we are going to take the flex pendant, and with this we can control the robot. And I will now acknowledge that the system knows that the chisel folder is on the control unit, and I do that with press with play. Okay. And now we can go to the robot to set the origin, to set the start and end point, and to run a dry test. Always when we are going to work with the robot, wear a hard helmet, because for safety reasons, we are working in manual mode, but for safety reasons, just wear your helmet. So the robot needs to know where its origin is, so where is the 0.0.0 point of Rhino, and with that we are going to jog it manually to that point, and we can set that origin. So I'm now moving it manually to the origin point, and then I know that's the point where to start. And the robot knows where the 0.0.0 is. Yeah, so that's it. That's perfect. Now I have my 0 point, and that's also the base of my model. So now I can set this point, and we are ready to go. Yeah, like this. The second point is our starting point. When we go to print, we need to mix some material, and for that we have some waste material. So we need a starting point where we can start a system, and we have here a wheelbarrow. So we have a waste of like 1 wheelbarrow. We will place the starting point right here, and then we are going to print. Starting point is also always a point where the mixing pump system operator and the robot operator can see each other and can easily communicate with each other. So now I'm going to jog to the starting point. Okay, that's it. That's a good starting point. Right now I will set this, this is my new starting point. Start position. Yeah. And the last point I have to set up is the exit point. Exit point will have it a little bit higher. So when the object is printed, it will go to the top and will lower to the beginning point. So for that I will raise it a little bit, like there. So the printer will go the top layer to this point, and that will drop to the beginning point. Yeah. So now we have our origin set, we have our exit point set, and our starting point. Next thing we are going to do is we're going to check the bottom layer of the model if the model is set up correctly. For that, we can do it also in manually mode. And for that, I'm going first to the starting point, because the starting point is the place where we're going to start up the material. Move to start point. Okay, so that's working. From there we can go to the print, and we're going to print from the first pixel. So we can start. And you see we are going to print right now. Now I have to check if it's going right. Yeah. And now we are checking if the height is correct and if everything is just printing like we expected on the model Rhino. I have also a guard stop. With the guard stop, when I'm squeezing it or when I'm losing it, it will stop the whole system. So when something unexpected will happen, I just can clamp it or I can lose it, and then the system will stop for safety reasons. So that's all in manual mode, because that's of course the most safe mode to set up everything. We are still checking if everything is going as planned, and we see okay, the height is good, so looks good. And we wait until the jump to the next layer. Now we know okay, first layer is good, is correct, so that's perfect. Yeah. So now it's going to the next layer. And I will stop the system because now we'll fill in the pixels of the last layer, so we can check the last layer. Yes, there we are. Now is going to print the last layer. And we will also check if the last layer is printed well and as expected. And from that last layer, it will go to the exit point, back to the wheelbarrow, and then we can close down the maximum pump system. We have now quite an easy and small model. If you have a really big and complicated model, we always advise to do the old dry test or some more layers, so bottom layer, 2 or 3 middle layers, and the top layer, and also preferred to do automatic dry test. But for this model it's quite easy, it's only the bottom layer, top layer, and the exits, and from that point we are ready to print. There. I think it will be the exit, so now it's going to the top. From there it will go to the starting point again. And then I can say to my mixing pump operator, You can shut down the system, and you can flush the hose, so the concrete what is still in the hose can be cleaned. So that's about it. The next step will be starting up the mixing pump system, setting the lastings ready, and yeah, you're ready to print. And that's it, I guess, for now. So that was the dry testing, one of the most important things for the safety, to know for an operator what the robot is going to do and how it's going to move. Done the dry test manually. Now we're going to do the dry test in an automatic way. And with the automatic, we will do the dry test completely, so not only the bottom and top layer, but the whole print without material. For that, we are standing here at the control unit and turn the key to automatic. The next thing we do is next thing to do is we are turning on the motor. Yeah, the motor is on. And the robot is also on. Now the last thing is we have to start the print right here. So we are going to the artisan, press print, and press start. Now everything is ready, and we can press the green button on the system to start the print. The green light is flashing, so that's a sign that the print is ready, and then we are going to we can start the dry test, the automatic dry test. To start the print itself, we need the remote control, and the robot operator always can use the remote control to control the robot itself. And what we now have to do is to press the green button, and with the green button the print will start automatically, and with this one we can regulate the speed. So we will start a bit slowly, and then we'll do the dry test on full speed. As you can see, it is going from the start position to the bottom layer. And for safety, I will check. Okay, everything is going good. So now I can speed up the system. As you can see, the system is going quite fast. So everybody needs to get out of the printing range. Pause the system. Normally we should follow the whole print path, and now we will close the video. When the print is done, we have checked everything is ready, and we should be ready to print. What we have done with the automatic dry test is the same as we will do during printing. So the mixing pump system operator can start the material. We have to check if we have printable material, and we can just, with pushing the green button, we can start the print, and we'll start printing.
Testing. As you saw in the very beginning, we have this incredible system on how to check that the printer nozzle doesn't go too low. Someone puts his finger under there, and as soon as he says "ow," we know that we've reached the perfect place to start, which is of course a joke. You should not put your finger between the ground and the nozzle. But yeah, so that was the dry testing. As Jesse explained, manually we do the bottom layer, the middle layer, and the top layer, especially in prints where there's nothing nearby. We know it's going to go well. We just want to check if the correct model and the correct parameters are in there. For more complicated tests, or for the very first time that we print a certain model, we might do the automatic one, which follows the complete toolpath, just to check if everything is nice and safe before we do the actual print. It depends on the situation which one you choose. Of course, the manual one, checking 3 layers, is a lot faster than doing the full toolpath. but sometimes safety takes priority over the time that it takes. So that's that. Don't know if there's any questions in regards to dry testing. If so, please let us know. I think it was quite a clear fragment. Of course, we have a finishing poll. And yesterday talked about this very shortly. The program that you saw on the Flex Pennant is one of our own softwares, Artisan, but we have two other softwares that we use. One is ours and one is not ours, which are Rhino and Chisel. And we were wondering if you guys were maybe already familiar with both of them or either of them. What are those? That's our moderator being funny with those answers. I've heard of Rhino, but Chisel is new to me. That makes sense. So Rhino is, for the people that know, is a 3D architectural software or a 3D modeling software that's used in the architectural world and construction world quite a lot. Chisel might be new to you. That's our own software. That's actually the add-on that we have written for Rhino, which is our slicer. And this actually transfers, or this converts, I should say, converts a 3D Rhino model into layers, and after that into a toolpath that our robotic arm, our printer, can actually follow to make a print, which is pretty much the same as with every 3D printer. Whether it's a plastics one, a metal one, or a concrete one, you need to cut your model into slices, which is why it's called a slicer, for it to print. And then the other answer, I know of them, but wouldn't know how to use them. That makes sense. If you don't have our 3D printer yet, then it's complicated to understand how Chisel works. Rhino is something that you can learn externally from us. You don't need CyBe to learn about Rhino. That's a independent software that's not owned by us in any shape, way, or form. But it's a very convenient software to know, especially if you're in architecture, designing, or construction. It's one of the more used 3D designing softwares for construction. And then I think, yeah, there we go. We get to our Q&A. So quite a lot of new information, maybe for some people. For other people, might be a bit of a repetition of the information. But I'm wondering if there's any questions in regards to this webinar specifically, or in general about CyBe, about 3D construction print. Let me know. That's wonderful. That might be the very first time that everything is completely clear.
Yeah.
If that's the case, then I wouldn't want to hold you any longer. I'll wait for a little bit just to see if people are still typing their question, which of course can happen. If the question does come in, I will answer it. But if not, then I would like to thank you all for attending, even though it is a replay of a different webinar. There we go. I thought so. There's a question. If I want to print on a surface that is not level, how do I get the printer to adjust for the unlevel surface? So there's a couple ways you can look at this. If it's an uneven surface, then that becomes complicated. You can accommodate some unevenness due to the material being quite wet. Especially for the first layer, you can make the nozzle go a bit slower, which means that you can actually fill bumps if these are not bigger than one layer width, which is around 12.5 millimeters, which would be, let's say, a third of an inch, a little bit more. If the floor is completely unlevel, but if it's unleveled but it is flat, then that's not a problem, because when you do the 0 point, you also do a calibration, meaning that you can touch it on 2 points or 3, so that the robot knows how it compares to his digital world, how it compares to the actual world, so it can accommodate for a bit of slope. But if it's completely uneven, like on rough sand or something, we would not recommend. But if it's uneven, you can just calibrate it and it will know it's a bit off, and you can still print. If it's very off, you might not want to do that with risk of the element sliding away. But in general, if it's a couple of degrees, the software can accommodate for this. So I hope that answers your question, Robert. Hello, Francois. I will, of course, take a look at your latest email. I did see it coming in, but I was quite booked for the day. But I will get back to you tomorrow. Thank you for the heads up. All right. If that's all, everybody, then again, I would like to thank you very much. No, it will not stretch the model per se. All right. I know what you can do, Robert. If you shoot me an email, I will show you some documentation, but it can accommodate for a slope in two ways. It can either, if it's a very tiny slope, you can understand that the robot will print this way, which is not what you want. But in the slicing software, you can also include that so it knows that it has to accommodate for that a little bit. There's a couple of ways to do this, but I can tell you a little bit more about that. In general, we do advise to level the printer in the same way as the surface you will be printing on. It's just a lot easier and a lot less preparation work. But if that's not possible, there are ways to accommodate for this. But I can explain that further if you send me an email. And you can send that preferably via the CyBe contact form. This goes for everyone. If you're interested in us printing a project for you, if you would like to buy a printer or get in touch with me with general questions, please reach out via the contact form, and then we can get in touch. Frederick, thank you for your question. What's the level of earthquake resistance? Well, as you might know, earthquake resistance is usually not purely based on material choice or construction method, but also on design, meaning that if you have, we print these walls. In the walls are cavities, and in these cavities we can place rebar and fill it with concrete, meaning that you have a reinforced concrete structure within these walls, and you can use the walls partly as lost formwork or lost scaffolding. In the case of a very high earthquake requirements, you can make these cavities bigger, add more rebar and more concrete, the same as what you would do with a normal reinforced concrete structural frame. So you can just increase the size of the beams and columns that you use. So that's the solution that we use. This way of construction and this way of using the technology also allows you to use the technology worldwide, because you don't have to add 3D printing into the local building code. You can use standardized beams and columns for your structural elements, which structural engineers and architects around the world can calculate on, and municipalities and governments can approve of, because it's a standardized construction method. So this way we can actually use technology worldwide instead of having to get building code updates for every different location that we print. So I hope that answers the question. Piping or wiring before or during printing, for example, in the floor, is it difficult to set the movement of the robot to avoid crash? So we don't add the piping or wiring during the print. What we can do is we can print the cavities in which the conduits in which the wires and piping go, which helps with the post-processing. So you don't need to do any post-processing to the walls. We do not like to do a lot of installation in the walls during printing. Also in the floors, we don't print floors with this robot specifically. We have a different construction method that focuses on that called PPVC. I believe we have a webinar about that already, and if not, we will in the future. So keep your eye out for that. Let's see. Technically pretty difficult, but as a massive summary, separate left. Thank you, Chris, for answering Robert's question. Let's see if there's you need to make a leveling up print. Exactly. Correct. you don't want to do the scanning and complete adjustment of your model. You can do this. We have done a couple of experiments for a customer as a research case that actually had a broken piece of wall, just a brick and mortar wall, and he wanted to print. It was a diagonally broken stepped wall, and he scanned that. He actually put it in his software, and with angled printing, we tried to replace the broken elements as a research project. It can be done, but it's honestly not worth the hassle. You might as well bring the wall down, or if it's a very expensive wall, it can be done, but we don't advise on doing so. Two-stage print isn't reasonable. Correct. Well, again, it can be done, but then you have a wet on dry connection, which means a poor connection, which means possibility of cracking. There are ways of doing this again, but we assume that you have your slab for your building casted quite recently because you are on the construction. So you have a nice flat slab, and on this slab you can print these walls in a stable manner. If you do want to print on an uneven surface, you might want to ask yourself the question, is this surface stable enough to actually carry the wall? Is this surface going to be around enough for it to be worth placing the wall? Questions like that come into play. So in general, you would like to print on a nice flat surface. All right. Cool. All right. Thank you, everyone. I think that's it for us at this stage. I hope everyone enjoyed their holidays. I didn't ask yet, but I think they're over for most of you. For the people that are still looking forward to a quick break before the year begins again for most people, I wish you a very nice holiday, and we will see each other hopefully next month with our next webinar. Thank you, everyone. See you next time.